we're going to take a look at how to calculate slope from a graph. Now, there are basically 4 ways to describe slope, just in general. You can have a positive slope value. You can have a negative slope value. You can have a slope that will be 0, which is also the value itself. And you can also have a slope that's going to be known as undefined. So if you notice the 0 slope, it is completely horizontal, as if you're just walking along straight with no incline or decline. There is also what's undefined, as if you think about going to the edge of something like a cliff and looking over and it goes straight down. So there is really no value, it is undefined. Okay, so the run value or the x value is 0 because it's not going left to right. Versus here, the numerator or the y change, it's not going up and down. That's 0 even though it is going left to right. So really from a graph, you should be able to start to quickly identify that's 0, that's undefined, no numbers really needed to calculate. I will prove to you why it's 0, why it's undefined, and we can do that by just picking points. So if I look here, you can pick any 2 points you want. We've talked about this from a data table. And let's say I take the y-intercept, right? So I have a 0, 1, 2, 3, 4, 5, and I'll just take this one, 1, 2, and as well as 5. So I've taken 2 points. You can practice and pick the other 2 points, see if it still works. Remember, those are your y values. Those are the numerator difference. These are your x values. Those are your denominator differences. So your numerator is 0. The denominator is -2, and so anything 0 divided by a number is going to be a big old 0. 0 is not negative, it's just 0, 0, 0, so that's your final answer of 0. So just proof why it's 0. Undefined, we'll do the same thing, pick some points, 1, 2, 3, so that's -3, +1, and let's say I'm still at -3, 1, 2, 3, 4, 5, and now I'm just going to do the same thing. Again, your y values are the ones in the numerator. Your denominator values are your x's. And so this would be a -4. Anything minus itself or keep change, make it its opposite, that would be 0. And if you plug that into the calculator, it would give you a big error. And so basically any number divided by 0 is what we call undefined. There is no definitive value. Now we're going to go over to positive. Here we go. Great, it's positive. That's how you can describe it. Or just to let yourself know, make note, when I get my number, it better be a positive number in the end. So we can do this by counting. And right now, if you notice from the other examples, every blue line jump is worth 1. Please always double check. Sometimes your graphs go by 2s, by 3s, by hundreds, by 10,000s. It all depends on the graph itself. So we can take 2 points and figure out, okay, if I'm from here to here, it's a straight line, so it doesn't matter which ones I pick, how many jumps up? 1, 2, and up is a positive, and then how many jumps over? 1, 2, 3, and since it's to the right, that's positive, and your up is your what we call rise, and then your over is what you call your run. So now you've got 2 over 3, and that is your slope, 2/3. Now this is great, but again, you want to be able to make sure when they aren't going by 1s that you're very careful, and so let's practice by taking the points. So let's say I had this point right here, that would be 3, -1. And then I'll take this point down here. Well, that did not go left or right, that's 0. And then it went 1, 2, 3 down. And then again, I'm going to take the difference, minus -3, all over 3 minus 0. Remember, keep change opposite. So change, make that its opposite. So that's really 2. 3 minus 0 is 3. And oh, look at that. You still have the fraction of 2/3. So this slope value is 2/3. For every 2 up, you go 3 over. 1, 2 up, 1, 2, 3 over. Yay, I'm back on the line. 1, 2 up, 1, 2, 3 over. It's a pattern. That's why your data table shows a pattern. Same idea here with the negative. Again, everything's going by 1. So let's say I just go here. I go 1, 2, 3, 4, 5, 6, 7. I stop there because I'm directly across from the next point. And that was up, so that's plus 7. But now I'm moving to the left. 1, 2, 3, 4 jumps, so that's minus 4. So remember our rise all over our run. But our final answer, we've talked about, don't leave that negative with there. Put it either directly or front, or you can even go with the 7. It's okay because you can think about it as 7 down, which is negative, and 4 over to the right, which is positive. That's why a lot of you just keep it in front of the fraction. You should be okay. Again, let's take that point and test out our formula. 1, 2, 3, 1, 2 down. And I'll take this other point. Negative 1 over, and then 1, 2, 3, 4, 5 up. And then let's take our y values. Negative 2 minus 5, 3 minus negative 1. Guys, I would highly suggest for some of you, say this out loud just like I'm saying out loud. It reminds you to put minus. And when is it minus a negative versus minus a positive? So here, I'm just going to take one extra step to remind you guys of how to do our positive and negatives when we have subtraction. So negative 2 plus a negative 5, right? Keep it, change it, make it its opposite. And then we're going to have 3 plus 1, right? Change it, change it. So now you are back to negative 7 over 4, and look at that, you have the same slope. So for every 7 you're going up, you're going to the left 4, or for every 7 you're going down, you're going to the right 4, but it is a negative slope. So there you have slope from a graph.